Hey guys, I wanted to post an update about my Lefty to the video I have posted probably nearly a year ago now. Thank you for everyone who commented, because these comments have pushed me further in my thinking. So this spring, I didn't know what it is for. It is a negative spring and it really helps to have a more linear curve for the fork. So I have to put it back in. I also had issues with the O-rings going on this piston. So basically I took it apart because it was leaking, and so I have to replace these O-rings. And once I took it apart, to be able to take it apart properly, I formerly used my self-made tool, which I had cut in the last video. Issue about this, it's steel, it's not really deburred, it's scratchy, and I don't want it to scratch that nice aluminium rod, which is a sealing surface, so it should remain intact. So what did I do? I fired up my 3D printer and I created this tool. On this end you have the 4 pins that need to go in here like that to be able to unscrew the whole damper. And on the other side I have 2 pins with another diameter that are made to go in here. And so I will put this on GrabGuide. I will put the link down below. So if someone wants to 3D print this part, and actually these are M3 screws, I just screwed into the massive plastic. It's printed with 100% infill, so it's really solid. So you just screw in M3 screws and then cut the heads off, or you can of course take screws without heads if you have that handy. And so that gives you this tool, which I will use to open up my damper, because through the air leak, air came into the damper from down here, because underneath is the air chamber, and this air that went into the damper pushed out the oil. So I already have air back in my oil damper, which I don't want, and since everything is apart now, I will also refill that one with oil, and that's where that tool comes in handy. Yeah, and actually it's the first video I do in my reorganized workshop, and I'm so happy that I have a workshop which is well organized now. Working like that makes much more fun. Like I have this tool trolley, for example, where all my tools are. So first thing to do is find the right screwdriver. This one is too big. Ah, here it is, a thin cross screwdriver. So first I open up here, and yes, maybe you hear it, maybe you don't. Now the air is out. That's what I wanted to do first, because I don't want to open up the big cover up here while there is still air in it, because that would pop out and give us a mess with oil and stuff. So now that the air is out, I can apply my tool, push it into the holes, and carefully unscrew the lid of my damper. And of course I am very happy that my tool works as intended. Now it is open. Yeah, I mean, having screws here is not ideal. Of course a cylindrical pin would be better, but it's much easier to put it in, and it does the trick for now. Yeah, I have probably 2 centimeters of lacking oil in here already, which is probably down in my oil chamber, so I will have to drain it from there. But now I'm ready to refill my damper. So now I have the new O-rings which were lying upstairs. I have the damper oil, syringe, suck it in. Over here is my damper. Move it to get rid of the air bubbles. You see the bubbles? Maybe I come closer. See all the foam we have up here? I'll let that foam settle a bit. In the meantime, can show you something else I've done. So that is that spring, with the one I had removed and regretted having removed it, and I put it back. And originally you had these bushings in the middle of the spring with an O-ring around to keep them in the middle, because the idea is that you don't want the spring to bend like this while it is not, because the rod extends to half of the length of the springs in fully extended position, and when it comes back into. And so, as I understood the engineering from Cannondale, you want to have some plastic in between the spring and the aluminium rod in the middle, because the aluminium rod is anodized, is a smooth surface, because it's a sealing surface. And so I've created this part, which in my idea is a better design, which I have 3D printed. You still see the artifacts from 3D printing, and that makes, I have a second one in here, and so with these little stripes, they interlock, and so it gives me a telescopic support in the spring. So if I put this one in, you see the idea, so that, and then I have actually supported the whole length of the spring, and if I compress it, these stripes they overlap, and so I have a very nice support for the spring, so it stays straight and it's never gonna touch the rod in the middle. So these are the 3D printed parts. I will put them on GrabCAD, so if someone wants to download the design and use it, feel free. And as in the last video, feedback is very welcome, because it's your feedback from the last video that made me learn about my mistake. And in the meantime, over there are no more bubbles. I try to do it with the most open position for the damper, so that we have big holes where the... that's the thing. That's something to be avoided. I should not pull it all the way up, because if I pull it all the way up, the piston comes over the surface, and if it comes over the surface, of course, it takes some air back down. So I should just move it in this lower part. That is a great way to break the bubbles. Just stir it slightly, and that gives me about a feel where the liquid level is, where the bubbles are. And now I close it. I know it is overfilled. It will overflow slightly, but that's actually the goal, hoping that it would make the whole assembly as air-free as possible. Little skirt around this tool. Screw that cap back in, much better than with the pliers I did last time, because biggest advantage is that I'm safe against scratches on the rod, because it's all plastic. And yeah, that's the end. Now it's tight. Here we go. Yeah, maybe one or two tiny bubbles left, but it's definitely not that bubbling I had before. Double check if this one is tight, this one is tight. So, and now Cannondale had this tight washer, I think it's PTFE, and I guess it is to have a sliding motion allowed on that bottom, because the spring might rotate a bit while you compress it, the end of the spring, so you want that this can move as freely as possible. And I think now you see the interlocking stripes. I carefully align it that it properly fits, and I made the tip of these little stripes also pointy, so that even if they come too close to each other, they should find a way to pass each other without colliding. Then I have a second one of these down here, O-ring number 2. And so, air piston, this spacer, and the whole assembly for the damper. So that's how it goes into the Lefty back again, and I hope this time it will work for a little bit longer than last time. Or at least I won't lose too much oil in the damper, or if I lose oil in the damper I will have to replace these seals. But since now I have a semi-professional tool to take the damper out, this will be much easier than last time. So now we are in front of the bike again. Can look down with my flashlight, and surprisingly it looks pretty dry down here. I was scared that there would be some oil that had leaked out of the damper due to the air coming into the damper, but no. Now comes the tricky part. We need to get that thing properly aligned. Yeah. Now it's in. It has to go past the thread with the O-rings, which of course always is a bit of risk of damaging the O-rings, but I hope that this one pass did not hurt the O-rings too much. Now comes the spacer. In order to get it all in, of course you must open up the valve on the bottom, so you're sure that the air goes out. Yeah, so the air piston is in. Where's my damper? Now as you see, this one is falling down, which I don't want. I want to keep it in place. So here comes the old grease trick. For the mechanic, grease is like glue. Let's put a little bit of grease down here for the assembly. I mean, it's anyway a good idea to have this thing well greased, so put more grease on the screw. See, now everything holds nicely together, and go down into the hole. Yeah. Now again, be sure the air goes out, and now you can tighten. And what you see, my old tool had 2 levers, and this new tool has only 1 lever. It's because of the collision with the rest of the bike. Actually, you see how I rotated the handlebar just to enable the rotation of my old tool. With the new tool I could even leave the handlebar straight, and then it's just like doing half a turn, go catch it, another half a turn, back. And now it's just doing these about 10 or more turns needed until it's tight. Yeah, but since I have built my tool, as you see here, it has 1 millimeter of play between the rod and the tool, so it's always perfectly aligned. You can just push it down, it catches the castle head, and then it works. It tightens. Yeah, it gets tighter, and I think, yeah, now it's tight. And my tool is strong, really, so I'm not worried at any point that it might break. And if I look at my little M3 screws, they are still straight. Happy with my new tool. And now comes the rest. These two halves here. I'm still not sure in which direction. Oh, it's written. That's the top. So this direction. This one here. This one here. Like that. Not on top. Push the whole thing down. To the ugly part, I still don't have the right tool to tighten this. I still have to use this brutal method here, but it's just for a few millimeters. Another scratch, but I call that patina. Now comes the lockout lever. Careful not to cross thread that tiny aluminium nut down here. 10mm socket. Gently. Okay, still moves. Actually, I don't use the lockout ever, because if I lock out my bike on the way up, I forget to open it up on the way down, so that's why I just don't do it, but that's everyone's personal choice. This little cap on top, align the tiny screw with the flat part on the shaft. Tighten it. Now it's tight. Yeah, and so I can close my damper, open my damper. Yeah, I even feel the index that's inside. Yeah, time for a good pump. Not sure if you see it, but it's already moving up. Moving up, moving up, moving up. So, I'm at 5 bars now. Let's check how well it works. Yeah, feels good. I think for a first test I'll go up to 10. Just to make sure everything is tight. Realign the handlebar so I can test it properly. Actually, have you seen that's a phone holder I made myself. And actually, if I look like this, I can use the phone holder, look through it under the tire to give me a help for alignment. Feels good. I mean, the final decision how good it is will be done on the track, but spring can come. Let's have a ride with it as soon as temperature gets a bit warmer. Thanks for watching, thanks for your feedback actually, which helped me a lot, and I hope my parts might become useful for someone. You can get them on GrabCAD. So have a nice day, bye bye.